Today's lesson is on the area of circles and covers pages 201 and 202. Our first question for today's lesson asks you to estimate the area of the circle by finding the area of the shaded part. So, first step is to find the area of each shaded shape in the top right quarter of the circle. So as you can see here, they've broken it into a lot of different sections, and we're just going to count how many shaded boxes they have for each one. In the first one, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why they put 12 there. If we look at the next box, it is 3 by 3. So that would give us 9. Our next box has 4 and 1 more, which is 5. And then we have another group of 5, a group of 9, and a group of 12. The box in the middle is 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 81. Then, if we look at part B, it asks you to add the areas in A, so these are the areas we found here, to get the quarter of the area of the circle. So, 81 plus 12 is 93, plus 9 is 102, plus 10 is 112, plus 9 is 121, plus 12 is about 133. So that's what we would put on this part. Part C asks you to find the area of the shaded part of the grid using your answer in B. So we're looking at the whole circle. So if there's 133 here, it means there's also about 133 in each of the quadrants. The easiest way to calculate this is to figure out 133 times 4. So that gives us 12 plus 1 is 13, plus 1 is 5. So that gives us about 532. Next, we're going to focus on question 2. The radius of the circle above is r equals, so we have to count how many it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units long. So we'll go and write 13 beside r. Divide the area you found in question 1 by r squared. So the area we found in question 1 was 532. They're asking us to divide this by r squared. Now, this would be like r times r. So r squared is the same thing as r to the power of 2, which is r times r. And our radius is 13. So 13 times 13 is 169. So this means we need to divide 532 by 169. The answer to this is about 3.1479. And what you might recognize or notice is that the first 3 digits are the same as the digits of pi. The last question asks you to explain why the area of the shaded part is a good estimate for the area of the circle. You could talk about how even though some of the blocks are outside, they also didn't include some of the blocks on the inside, so it kind of evens out in the end. Next, we have an investigation. Now, in class, we'll go through this together, but at home, if you aren't at school today, you'll need a piece of paper and to follow the directions. So, we're investigating what the approximate relationship between the radius of a circle and its area is. The first thing they're going to ask you to do is draw a circle with a compass and cut out the circle and fold it into 3 halves. So you take another piece of paper, cut out a circle, fold it in half one more time, and then in half a third time. Now, the next step is to unfold your circle and color 1/2 of it. You can see how they've shaded in half of it here. Then they're going to ask you to cut along the fold lines of the circle and rearrange the pieces as shown on top of a sheet of paper. You're going to need a second piece of paper. So you're cutting on all of the fold lines, so you should end up with 8 pieces. And then laying this on top of a second piece of paper, you're going to arrange this so all the shaded pieces are on the bottom and all the unshaded pieces are on top. Question C asks you to draw a parallelogram around the pieces. A parallelogram has 2 sets of parallel lines. So this shape they've drawn is a parallelogram. On your blank piece of paper that these cutouts are lying on, you're drawing a parallelogram. Remember to use a ruler. The area of the parallelogram is almost equal to the area of a circle. If you look here, there's a little bit of a difference, but it's almost the same. Question D asks you, is the height of the parallelogram in C approximately equal to the radius or the diameter of the circle? Now, if we are to look here, your height is a vertical distance. If I come in here, does it look like it's about equal to the radius or the diameter? Well, I can look and see that this would be a radius if I'm going from the tip to the edge of a circle. So it's more like the radius. E asks us which fraction of the circumference is the thick line here. So which fraction of the perimeter is it? Well, it's about half. Where would this thick line be if you moved it to the parallelogram? So if we were to move this to the parallelogram, the thick line would be the outside of all of the shaded pieces. If you'll notice, it's quite similar to the base length. Question F asks you, how can you get the approximate length of the base of the parallelogram from the circumference of the circle? Well, we've just noticed in question E that it's about half of the circle. The formula for the area of a parallelogram is area equals base times height. Use your answers for parts D and F to give the approximate area of the parallelogram. So, if our approximate area is the approximate height, which value is about the height? Well, we called that the radius. So if we were to write this in here, we could write radius. Our approximate base is about half of the circumference. So we could call that circumference divided by 2. Now, H gives away the answer and tells you that the correct answer to G is the area of the parallelogram is about the radius of a circle times the circumference of the circle divided by 2. We're going to substitute R for the radius and C for the circumference. So the area of a parallelogram is the radius times the circumference divided by 2. The circumference of a circle with the radius r is c equals 2 pi r. So if r equals circumference divided by 2, that means we're going to replace c with those 3 blanks here. So c is the same as 2 times pi times r divided by 2. Then we can look and go, okay, we're going to rearrange our order a little bit. So we're going to have pi times r times 2 divided by 2. So if I look at that, I put pi, I've used that one, r times 2 divided by 2. I've used all the same letters and numbers and symbols, I just changed the order. Then we can simplify. So r times r is the same as r squared, and 2 divided by 2 is the same thing as multiplying by 1, which doesn't change the answer, so we don't need to include it. The only thing we have left is pi. So it's equal to pi times r squared. The area of a parallelogram is approximately equal to the area of the circle. Mathematicians have shown that the actual area of a circle is given by the formula area equals pi r squared. So you'll remember from yesterday, I showed you this formula. So don't get confused with circumference. So circumference is 2 pi r and area is pi r squared. Question 4 asks you to find the circumference and use 3.14 for pi. Remember, if you use the pi button, you won't get the same answer as your answer key. I'm going to give you an example where the radius is 4 meters. So we know that the area equals pi times r squared. So we're going to substitute 3.14 for pi times 4, which is our radius, squared. Now, 3.14 times 4 squared, well, 4 squared is 16, and then you can use your calculator for the last step. 3.14 times 16 is about 50.24, and I have to remember to go back and look at my unit. Meters squared. Because I'm looking at the 2 dimensions and I'm finding area, my unit always needs to be squared. Question 5 is going to ask you what the area of the circle is, given the diameter. Now, we have our formula that area equals pi r squared. We don't have a diameter in this formula, so we need to calculate our diameter, our radius from the diameter. Now, diameter divided by 2 equals our radius. So 14 divided by 2 is 7. This is what I'm going to use for my radius. So pi is about 3.14 times my radius is 7 squared, which means 3.14 times 49, and then I'm going to use my calculator for the last step. 3.14 times 49 is about 153.86. Remember, we need units, so my unit was meters, and because it's area, I need to use meters squared. That's all for your lesson today. Let me know if you have any questions, and good luck.